Right, hi guys. I'm going to speak to you today about errors in the normal distribution, and I'm going to do it by going through this question so we can talk about the type 1 and 2 errors when we're going to do this type of question. So it's a normal. So here's the question. It says bags of sugar having a nominal weight of 1 kilogram are filled by a machine. From past experience, it is known that the weight, x kilograms, of sugar in the bags is normally distributed with a standard deviation of 0.04 kilograms. At the beginning of each week, a random sample of 10 bags is taken in order to see if the machine needs to be reset. The test is then done at the 5% significance level, with H0 being mu is 1 kilogram and H1 being mu is not 1 kilogram. And the question for a start says, find the critical region of this test. Right, there's a few things that are important about that. First of all, we're taking a sample and we're testing that sample against a distribution. And the distribution of the sample means is always going to be x bar is going to be a normal, it's just distributed normally with mu and sigma squared over n. Remembering that we get a much narrower distribution if we're looking for the means of particular samples and seeing how they're distributed. So that's why it's the divide by n. So reading from the data, this one we've got x bar distributed normally with a mean of 1 and then a standard deviation of 0.04. So that's 0.04 squared and 10 bags, so we're over 10. Okay, so we've got H0 is mu equals 1 and H1 is mu does not equal 1. So that first thing is telling us that that's two-tailed. So I'm looking for two bits, and it's worth reminding that it's 5% significance, where that is 2.5% and that is 2.5% to make up our 5% significance. Now, if I look here, the probability that I'm behind that point is 0.975. And then this is 0.25, so that would give us our 1. So this value here, Z, the probability of it being less than or equal to Z, which is what we represent by phi of Z, is equal to 0.975. Now, if I look at my tables, if phi of Z is that, then I can work out what Z is. Now, the table that I've got says that 1 minus phi of Z is equal to P. So in this case, P is equal to 0.025. And if I look down here, that will tell me that Z is 1.96. And if you do loads of these questions in your revision, you'll know that that's a figure that comes up a lot. So this value is Z, and this value here is minus Z. So here we've got minus 1.962. And that's due to the symmetry of this, of the normal distribution, the standard normal distribution, and that being 0 in the middle, and positive and negative. So that's an interesting start. So now we need to find our critical values of x bar. Now I know that x bar minus mu over sigma over root n is going to, I'm going to look for these critical points here that are Z in the standard normal distribution, but I want to know what they are in this distribution here. So I'm looking for plus minus 1.96. If I rearrange that, I get x bar is equal to mu plus or minus 1.96 sigma over root 10. And if I put my values in, so I know that mu equals 1, sigma equals 0.04 and n equals 10, I get the two values of 0.9752 for when it's minus and 1.0248 for when it's positive. And there's a plus in the middle. So what I've got then is my critical region is that x bar is less than or equal to 0.9752. That's this point here, and x bar is greater than or equal to 1.0248. And the interest in that is that if I weighed 10 bags of sugar, 10 bags of, it is about 10 bags of sugar, and if it came out less than that, I would know that the mean of them came out less than that, I would know it needed resetting. And if it came out as more than that, I would know that it needed resetting within the realms of our 5% significance. Now, that's part A done. Part B is really, really easy. Part B says, find the probability of a type 1 error. So that is the probability that it doesn't need resetting and you get a false result. And that's really, really easy on the normal distribution because of the continuous nature. And if you look at this graph here, you can see that, and that is equal to 0.05. That is always going to be the actual significance level. And then the question says, assuming the mean weight has in fact changed to 1.02, so I've got the mu is 1.02. What's the probability of a type 2 error? So what we're saying is, if the mean is now this, so I've got a new distribution, x bar is normally distributed with 1.02 and 0.04 squared over 10. And it's saying, what's the probability that I get a result that is would mean I would accept H0, but actually we are out of the realms. So we're looking at the probability that x bar comes out between 0.9752 and 1.0248. So I'm going to look at my graphical calculator, and for my lower bound on my normal cumulative function, I'm going to put in 0.9752. For my upper boundary, I'm going to put in 1.0248. My sigma is going to be 0.04 divided by root 10, and my mu is going to be 1.02. And when I calculate that, I get that my answer is 0.6476. So remember, That's the probability that we get something in the within, so not in the critical region, so something that's not in the critical region but is still errant. And this is the probability that it's in the critical region but it's actually okay. So hopefully that is clear. Okay, beautiful question this. Really, really easy to type 1 because of the continuous nature. You have to remember that it's always going to be exactly the same as the significance level given in the question. This one you have to work out a little bit more. But the critical region was the challenging part of this question, I feel. Okay, right. I hope that helps. Speak to you soon.